So before going through some examples with the pad stack editor, I decided to go ahead and talk about fiducials and vias as well. So remember in our first video, we showed that a via is really just a connection from the top of the board to a bottom of the board. Now, let me just say here, there is really no specified guideline for via design. Now, when I say that, there's no specified like formula for like, oh, make your via this big based off of certain things. Now, there's rules of thumb that some people follow, and then there's some other things that are really important that we won't take into consideration in this class. For high frequency applications, which is what we're not going to worry about, but high frequency applications, vias cause parasitic, capacitive, and inductive effects that can lead to signal degradation. In other words, what I'm saying is at high frequency, and when I talk high frequency and above 500 kilohertz, things can get really challenging. There's a lot of things. In some cases, you want to make smaller holes to avoid capacitance effects, but those typically increase your inductive effects. And so it's a balance game. And so it can be very challenging when you get to these really small vias and when we're talking about high frequency. There's also thermal considerations that you have to take into account as well, but we are going to ignore these in this class because this is a basic class. So we're going to ignore these. So we are going to have a general kind of what's rule of thumb here for us. So the general rule of thumb that we often, that I've seen several people use and that I've used before, is that you make the circumference of the via equal to your trace width. So let me kind of draw a picture here to kind of illustrate what I'm talking about. So I've got some chip here that's mounted on a board. So I'll have this red here is my circuit board. So I've got a circuit board here, and then I've got this chip, and it will be a surface mount chip, and it's going to have 6 pins on it. Okay, so then we have these traces, which I'll draw in red. So these traces, those are the conductive material that, is either going to have power or a data signal on it, and it might, kind of go along here. I'm trying to keep it the same width, but clearly I did not do it there. It might go along. And then we hit here basically a hole, and then the trace ends. This hole then, again, what I'll do is I'll draw this now in blue here. Might get connected to the bottom side of the board and then, wander around on the bottom side of the board. And maybe there's another via here on the bottom side of the board that then brings it back to the top side of the board. and then it gets connected into some kind of, connector here. And the reason you might use these again is when you have a complicated design, you might not be able to have all of the traces on the top. You might have to run some traces on the bottom. Okay, so the question is then, how big do I make those holes? Now, if you're talking about manufacturing them in the lab currently, we have to make them big enough to be able to either solder a piece of wire through it to make them so that you can actually get a physical connection from the top to the bottom, because if you just drill a hole through here, there's not going to be the top and bottom connected, because these boards are fiberglass, and then there's a layer of copper and a layer on the top and bottom. So if you drill a hole, there's no connection between the top and the bottom. So the only way to do it is we have a grommet system where it's like literally like little grommets that you put into each hole, and then you kind of punch them and flatten them out. And that can make a connection from your top and your bottom, or you stick a piece of wire through it and solder it on the top and the bottom. Now, in advanced manufacturing, and something that I'm hoping to get at some point at the university, is where we have electroplating, which then what we do is you drill the holes and you put your board in and you electroplate it, and so the holes get plated that way. But we don't currently have that ability. So the question then becomes, though, not what size of hole we have to make it maybe for us to assemble it by hand, but what's a general rule of thumb of what size should I make the hole based off this trace width here? And so the general rule of thumb here is that we make the circumference, well, I think I already stated that. The circumference, I'll say it again, the circumference of the via equaling the trace width. Okay, so let's do an example here. Let's suppose that we have a trace width here of 1 millimeter. What should the hole size be for the via? Okay, well, the hole size is not going to be 1 millimeter, because if we did the diameter of 1 millimeter, that's not equaling the circumference. Remember, circumference, we have to go back to geometry here. Circumference is 2 times pi times r, or because we're going to often want just the diameter, it's, I don't know where I got the m from. It is just pi times my diameter. And so if I have a circumference, well, my trace width's 1 millimeter, so my circumference I'm going to set at 1 millimeter for my via, and then this would be pi times my diameter. And I'm going to just do that on a calculator real quickly here. Just 1 divided by 3.14. And yes, I know that's not pi, but that's good enough for us here. So we have a via size of 0.3 millimeters. So D here would be 0.3 millimeters. And then we'd also want to put a copper pad around that as well. And again, there's not necessarily a specific set of dimensions as far as how much to put around that copper pad for that diameter that we've drilled, but you often are going to want that. But we also have to be careful sometimes, because if you put that, you can actually etch out something that you don't want to have etched. And so we'll talk about that when we go through the design here. But the via itself here, being 0.3 millimeters, is actually a very small hole. And we have drill bits that can drill 0.3 millimeters, but I don't let anybody drill that size of hole for us on our machine because those drill bits spin at very high RPM and they are very delicate and you can break them very easily. And actually, we've tried to do that, and I've gone through probably about 5 drill bits of 0.3 millimeters. The better way to do this is to actually laser etch those holes if you're trying to go that small. All right, so then we'll talk about the copper pad when we go through an actual example of creating a via using the pad stack editor. But that can help us determine the hole size. And I'll say maybe our minimum hole size, because we'll often make them bigger for boards that we are actually going to assemble by hand. All right, so then we also have here Fiducials. Now, there is no IPC standard for how big a fiducial needs to be. But because fiducials are used in manufacturing processes, that's where you have to sometimes use what manufacturing standards are. And so one manufacturing standard is SMEMA. I don't know what that stands for, off the top of my head, but for this particular standard, they state that the minimum hole size is 1 millimeter, and the maximum hole size is 3 millimeters. Now, vias also have a requirement for a copper or a clear path around them, essentially. Basically kind of isolating them from the rest of the circuit. Now remember, these fiducials, I think I said via there, I should have said fiducials. The fiducials have a copper pad around them, again, to kind of isolate them from the rest of the circuit. It's not really something you ever solder, but it's there to kind of isolate it from the circuit. Now, the size of that copper pad really, and technically you don't have to etch a copper pad away, but most people practice that as far as doing that. And there is kind of an IPC standard recommending what the clearance should be for a fiducial. And so let me draw here, my best here to draw. Got a circle inside here. And then you're going to see how poorly I can draw another circle around it. That's not the worst ever. Should be a little bit more rounded off there, maybe. Okay, you get the idea here. We've got 2 circles. Rounded off there a little bit. So we have the hole size here. And this has got, and I know we've been using diameters, but this has got some radius here to it. And we'll be able to use diameter here in a second. But here, this measurement x here, I'll call it x, x has to equal 2r as a minimum, or it's got to equal 3r, which is recommended, but the problem is that you can't always get 3R depending on the density level of your board and where the fiducials need to be. And even with the 2R, sometimes you have to make exceptions, again, based off the density of the board that you're assembling. but these are the IPC standards. Now, if we want to think of this in terms of diameter, well, can we say, okay, well, if I'm multiplying by the radius by 2, does that mean I multiply the diameter by 2? And let's think about this for a second here. Well, if I wanted to talk about diameter, okay, so that diameter versus this diameter. Well, I know that, and I'll call this D1, D2. I know that D1 is 2 times the radius, because that's just how we calculate that. And then my recommendation, I'll just do my minimum. So D2 needs to be 2 times 2R. So, but wait, 2R right here, that is simply the diameter 1. So, even though the spec is written, the IPC standard is written in terms of radius, we can still just use what we're used to using with, which is diameters. That if we have D being the diameter of my hole, 1 millimeter, then the minimum copper pad would be 2 millimeters, and the recommended would be 3 millimeters. And so that's it for sizing for fiducials. So they'll be between 1 and 3 millimeters. And you might say, well, how big do I know to make it? Well, some of it depends, well, a lot of it just depends on what the component is you're placing, what the requirements of the manufacturing are. I will say that for any boards we produce in-house here with our etcher, we will use a fiducial size of 1 millimeter. We'll always use that size for this. Okay, so let's go ahead and end the video here for now.